We are building the Fractals and Recursion project from the YByte Python curriculum available at www.ybyte.in. Previously, we saw how the square pattern is in fact very similar in logic to the tree pattern. Now we are going to get started building the tree. Remember, in the square pattern, we started with just one level of recursion, and that's exactly where I'm going to start. In fact, I'm going to write a recursive code to draw a single branch. Before writing this, let's just try to understand the structure of this a little bit. So basically, I create a function which is, let's say, two arguments, so size and the level. Size could be, let's say, 100, 200, whatever, the length of the branch, and level basically is like at what level the branch is. If level is more than 0, which means that becomes a base case. So if level is more than 0, I move my turtle forward, because remember, the basic drawing task is just to draw a line. I turn my turtle right to, say, by that angle, by a certain, so angle has to be defined elsewhere, or angle could also have been given as an argument here. But nonetheless, I turn my turtle, let's say, to a certain angle, and then I go and call the same function once again. So this time round, I reduce the size, so say 0.8 times size, and I also reduce the level. Now this is important because remember, if I started with the say level of 3, that will become 2, 1, 0, and at that point, the recursion would basically stop. So this to make sure that this whole thing stops, we have the base case and the recursive call. Let's see this in code. So I get back to my code here. I just create, let's say, a function called, say, def, let's say, branch, and I just do it, let's say, two arguments, size and say level. And for now, I'll just set the angle to, let's say, outside this function to maybe, let's say, 20 degrees, or we can play with this later on. In fact, this, like I said, could also be an argument, and some interesting possibilities, in fact, arise from there. But nonetheless, I start with, let's say, angle of 20. Now, I just put a condition that, look, if level is greater than 0, I will make my turtle move forward, let's say, by, say, size steps. I will make my turtle turn right, so t dot right, let's say, by the angle. And, I will recursively call the function. So it's branch, let's say 0.8 times, let's say, sz, and level minus 1. Now what that means is that as I run the function recursively, I will keep on calling this branch with a smaller size and a lower level. At some point, the recursion would stop. Now we will see this working, but before I do that, I'm going to clear up my, let's say, everything that the turtle is drawn. I will take my turtle, let's say, I'll put the turtle's pen up, because remember, by default, the pen is down. I will take my turtle to something like maybe 0, say, go to, say, 0 minus 200. So it's kind of like, a little bit down on the y-axis. And most importantly, I'll set turtle's heading to, let's say, 90 degrees, which means the turtle is now pointing upwards. And then I, let's say, so this basically happens by default. I will also put the turtle's, say, t dot bend down. So that, which means that, when I move the turtle forward as part of my function, it also ends up drawing. Let's see this working. When I, let's say, do this, now notice my turtle is basically ready, pointing in the upward direction. If I were to give a command branch, let's say, branch, say 100 and say 4, in fact, you'll notice the turtle will move forward and start drawing the right branch. Now see that how similar this is in a way to the square case, where we had the square going to the right side. Very similar, except that, like we discussed earlier, the children now are just lines. And what's happening is that, look, my turtle moves forward, turns, and again calls itself. So again, it moves forward and turns, moves forward and turns. So we'll look at it more closely. But we can take one more example. Let's say I do the whole thing once again. My turtle is ready once again. I can go and say, well, turtle, please draw me a, let's say, branch, let's say 8 level. So 8 level, it starts to even go down. Of course, it all depends on the angle. Let's say I made my angle, let's say, say 60 degrees. It's going to turn a lot more. When I do this, notice my turtle is ready. If I were to do the same thing, let's say with 60 degrees, in fact, turtle will turn back into itself. As we see here, turtle turns 60 degrees, turns back into itself. In fact, lots and lots of possibilities exist. We can play with this. We can stick with something like maybe 20 or 25. In fact, we can set the turtle's, let's say, pen color to perhaps, let's say, some other number, just to get an idea of how this looks. Let's say I do that. I can even go and set let's say turtle pen size to maybe, let's say 5, so the turtle is a bit thicker. Now when I call for my same branch function, notice it draws out a nice green line, right? Now this is just like a choice, you can make. Of course, you can always stick with just the regular color. Before wrapping this up, let's just analyze this a bit more carefully so that we understand what's going on. Like I said, before calling the function, I set the heading to 90 so that the turtle is pointing upwards. Thereafter, from the command line, I gave, for example, here 104. So the first line drawn is 100 because remember, turtle just moves forward 100 steps. Turtle then turns and I call, let's say, branch 83. Now, why 83? Because I'm doing 0.8 times, let's say, the size. So that's 83. Of course, 0.8 is just a number. You can also change that. So the ratio will change accordingly. Then I draw a second line. So the level was 4 here. Level became 3. I called again with 64 and 2 because remember, I'm doing level -1. So level was 2 here. I drew something at, let's say, 51. The level 4 is 51.2 times and 1 because level was 1. So at this point, I call the turtle again with 51.2 as size and 1 as the, let's say, level. And remember, at this point, recursion stops because when I call this recursive function with level of 1, this argument is 0. And when this argument is 0, I do not enter this anymore. So the recursion stops. I hope this has been clear enough for you to understand how this recursion is working. Like I said, and like we discussed earlier, just one more level of recursion with some care, and you will have the entire tree. That's the magic of recursion. We will do that in a little bit later. But this way of learning, where we build activities, we analyze things in detail, we go in a step-by-step manner, is how we learn Python at YByte. So do look at our website, www.ybyte.in, because we learn Python through such fun activities. Take care. Thank you so much. Bye-bye.